Let us solve this example. See, in this example, what we have a condition x lies in 0 and 1. And what we have to prove, if x lies in 0 and 1, then 0 less than x square less than x less than 1. So let us start with the given thing and then we will prove it. We have, what we have, 0 less than x less than 1. Okay, actually two things are there. It means 0 less than x, and second thing is x less than 1. I will focus only on x less than 1. So that is x less than 1. I will call it as inequality number 1. See, we have x 0 less than x. That thing also we have. We have 0 less than x. It means x is a positive real number. That is a very important thing we have got here. That is, x is positive real number. See, what I'm going to do, I'm going to multiply 1 by x. So let us see what will happen. Now, multiplying 1 by x. So if you multiply 1 by x, you will have x into x less than x into 1. Getting? So x is a positive number, that's why it is possible. One property we have studied, okay, that is, if a less than b and c is greater than 0, and if you multiply, you will have same inequality. Getting? If you multiply any inequality by positive real number, then we have the same inequality. But if you multiply by negative real number, inequality will get changed. Getting? So here we are multiplying by positive real number. We have proved it. It is a positive. So that's why we will have the same inequality. So what will happen? See, what will happen? Let me write it properly. So x into x, that means x square, and less than x into 1 is x. Inequality number 2. We have one more thing. We have what is the one more thing? That 0 less than x. This thing we have. Okay, I will call it as 3. Yeah, I will not call it as 3. So we have 0 less than x. So here also I will multiply both sides by x. Multiplying both sides by x. So if you multiply both sides by x, what will happen? Same thing I am doing here. X is a positive real number, so we will have the same inequality. So x into 0 less than x into x. 0 into anything, you know that it is 0. 0, x into x, we will have x square. So I will call it as inequality number 3. So therefore, from 1, 2 and 3. See, what will I have? In 3 we are getting 0 less than x square. Getting? In 2 we are getting x square is less than x. Right? And in 1 we are getting x is less than 1. So if we combine these all, we are having required thing. So in this way we have proved. Okay? You can make a screenshot of it, and after that we will go for next example. Let us discuss this second example. It is also very simple. Okay, so let us discuss its proof. What we have, that thing I will write first. We have that x greater than or equal to 1. Getting? X greater than or equal to 1. This is a given thing and we have to prove this one. I will call it as inequality number 1. See, but you know that 1 is greater than 0. Yeah, it's obvious. So x is greater than or equal to 1 and 1 is greater than 0. That means x is also greater than 0. So therefore, x is greater than 0. That means x is positive. X is a positive real number. So see, I'm going to multiply inequality number 1 by a positive real number. You know that when you multiply by a positive real number, we will have same inequality, and when you multiply by negative real number, inequality will get changed. See, multiplying 1 by x. See, what will I get? X into x greater than or equal to x into 1. So x into x, that means x square greater than or equal to x into 1, we will have x. So in this way we have proved. See, one result we have used here. That means if a greater than b and c is positive, greater than or equal to b, and if c is positive, if you multiply both sides by c, we will have same inequality. Since it is positive and we have proved it is positive, so that's why we could write it. Example is over. You can make a screenshot of it. After that we will go further. See, let us discuss this result. See, this result is not new for us. Okay. What this result says, x into y is positive. That is a given thing. Then they say either x and y, both of them are positive or both of them are negative. We know now product of two numbers is positive. That means both of them should be positive or both of them should be negative. But this thing we have to prove now. Okay. So see, I will write the given thing. We have what we have, x into y greater than 0. You remember that law of trichotomy. I think in our third or fourth lecture we have discussed that law of trichotomy. Okay, so I will mention by law of trichotomy. Do you remember the statement? Exactly one of the following is true. That means x is equal to 0 or x is greater than 0 or x is less than 0. So if you have any real number x, by law of trichotomy says there are only 3 possibilities, and out of these 3 only one will be true. That means either the number will be 0 or the number will be positive or the number will be negative. So here also I am going to discuss 3 different cases. First case, obviously I will take x is equal to 0. Case number 1, x is equal to 0. See, if x is equal to 0, x into y will be, I don't know the value of y, but I know the value of x. 0 into y is equal to 0. So that means we are getting xy is equal to 0, but it is not true since they are given x into y is greater than 0 and we are getting is equal to 0. So I will say it is not possible. It is not possible. That means this case is also not possible. That means x cannot be 0. So then if x is not equal to 0, then we have two possibilities. Either x is positive or x is negative. So let us go with this condition. Case number 2. X is greater than 0. That is x is positive. Okay, x is positive. What is the information we have? We have xy greater than 0. See, one thing I am going to do, I am going to divide both sides by x. Dividing both sides by x. See what will happen. See, x is positive, so that's why we can divide both sides by x and we will have the same inequality. So therefore, xy upon x greater than 0 upon x. X will get cancelled. So y is greater than 0. Here x will get cancelled, y, and 0 upon x is 0. So that's why we got y greater than 0. So that's why if we consider x is greater than 0, then we get y is also greater than 0. Therefore, in this case we get x is greater than 0 and y is also greater than 0. That means this thing. If I assume x is greater than 0, then we are getting y is greater than 0. Let us go for the last case. The last case is obviously x is negative, and I will prove that if x is negative, y is also negative. You can make a screenshot of it, and after that we will go for last case. Okay. See, let us discuss last case, that is x is less than 0. So that is x is negative. Okay. See, again I will go with a given condition. What we have? We have xy greater than 0. See, I am going to divide both sides by x. Dividing both sides by x. But see what will happen, x is negative, it's not positive. So that's why inequality will get changed. So therefore xy upon x, inequality will change here. Here we have a greater than, we will have less than. 0 upon x, x will get cancelled. So y less than 0 upon x is 0. So we got y less than 0, right? So therefore I will mention, therefore in this case we get x less than 0 and y less than 0, right? In second case we got both of them are positive, and here we are getting both of them are negative. So therefore from all above cases we conclude that all above cases we have either x positive, y positive, or x negative, y negative. In this way we proved. Okay, you can make a screenshot of it, and after that we will stop. Thank you. Bye bye.